real quick. A little bit about limits, little 10-minute ditty. It'll help, I think. Viviette, hello.
Hello.
So, and then we'll take the rest of the time to work on the web work. Limits, infinity, in brief, and infinite limits. Alrighty, so just some facts, just some simple facts. So let's talk about this first. So what that means is that my x is becoming larger and larger without bound. I cannot get to infinity. It is not a place to go. It is a thing to aspire to. So this just means x is growing without bound. And we're interested in the output. So let's take a look at a couple possibilities. If I have a function that looks like this, it's indicating that it keeps on cruising. This is my x-axis and this is f of x. Then this limit is infinity. Just keeps on growing. You tell me how big you want it, I'll tell you how far out you need to go to make it that big. And we can always play that call and response game. Limits are all about call and response. If the function was looking like this, let's say I had an asymptote, like this, a horizontal asymptote. So maybe that's -3 right there. And my function was doing something like this. Kind of like a spring, mass spring system that's losing energy or anything that's oscillating and it's just dying out. This is like an equilibrium state. And this, I would say right here, the limit as x goes to infinity of this function is -3 because it looks like it's getting closer and closer to -3 as I move out that way. And then we got something like this, and that limit would be -infinity. If in doubt, and you're working on these problems, you're like, I don't know what the limit is, get a graph out and scoot to the right. Grab Desmos, grab 2 fingers, pull Desmos this way, or whatever you gotta do to move out that way and analyze the y coordinate. Sometimes this limit does not exist. So if I had, for example, a sine curve. Wow, that is one weird axis, but this doesn't ever seem to settle down. So here, I would say the limit as x goes to infinity of f of x does not exist because it never settles down. In some ways, these are both does not exist. This is the only there exists a limit. The limit exists case that we really have. These are just subtle versions of does not exist. Does not exist can mean that, can mean this. If it was one of these two, I would clearly state that for whoever is reading this stuff. Does this all sound reasonable? Yeah? Okay, awesome. Okay. Here's some important functions to remember. If I have limit as x goes to infinity of a polynomial, so p of x, and so p of x is a polynomial. Does that make sense? Does anybody need me to define polynomial? It's powers of x with coefficients added together. So when that is the case, then this limit really only has 2 possibilities. It's equal to plus infinity if the leading coefficient is positive, and that's on the highest power of x, so the leading coefficient is greater than 0. It's equal to negative infinity if the leading coefficient is less than 0. So for example, limit as x goes to infinity of 3 minus 8x squared plus 2x cubed minus x to the 14th. I wrote it backwards just to be tricky. This is the leading coefficient, -1. So -1 equals leading coefficient. So this limit is -infinity. That's a good rule of thumb to know. If I want to talk about limits at -infinity, I actually would probably convert that to one of these problems. So let's just talk about that really quick. Okay, so if I wanted to do this of some function, I would actually rewrite the whole thing. So I would rewrite that as the limit as x goes to +infinity of f of -x. So I'd replace every x with a -x and simplify, and then just do all the rules that I know. I think that's a little easier. So do this and simplify. So for example, that one down there, limit as x goes to infinity, of 3 minus 8x squared plus 2x cubed minus x to the 14th. Oh, put a negative, sorry, -infinity equals limit as x goes to +infinity. And I'm going to replace all these x's. I'll do this slowly this first time. Use parentheses, like that. Even powers, the negative goes away. Odd powers, the negative comes out in front. So then this turns into this. Just still minus x to the 14th, because that goes to positive x to the 14th. There was already a minus. So now I got this, so what's the answer here? Where does this go?
-infinity.
-infinity, same, almost the same damn thing, but it doesn't matter what's here, it's what this leading coefficient is. So yes, indeed, -infinity. One last thing I want to tell you, probably be super useful. I actually don't think you're going to need L'Hopital's rule for that assignment. I might be wrong. Maybe we'll talk about it on Monday after we investigate, but let me give you one more rule that I think is helpful. Limit as x goes to infinity of a rational function. So P and Q are polynomials. There's like a nice little condition case for this, or case-by-case breakdown. So if the degree of P is greater than the degree of Q, this is going to go to plus or minus infinity. So the limit is equal to plus or minus infinity. And the plus or minus is determined by the ratio of leading coefficients here. So here the sign equals ratio of leading coefficient signs. And I'll do an example here in just a second. If the degrees are the same, that's awesome. Then the limit equals the ratio of the leading coefficients. I'll just call them leads, so I don't have to write the damn word coefficient. Wonder how many F's and T's are in it and all that stuff. Ratio of leads, and then if, this one's nice, the degree of P is strictly less than the degree of Q, then the limit is 0. Carla's shaking her head because that sounds about right. So really good rules to have around when you're doing this stuff. And I think let's just kind of call it there for today, and then on Monday when we come in, we might need to review some L'Hopital's rule. Let's see where everybody's at. Does this sound good? A little helpful here? Okay. But a key thing is get a graph out if you're really concerned. Like, oh, and here's a graph you might need in some ways. Arctangent. This happens a lot in math, this arctangent function. I seek it out because I love it. So just so you know that about me, there is an arctangent in homework of some kind. But this is a good graph to know. This is pi over 2, this is negative pi over 2. So help me out here. What is that limit and what is this limit? You don't need to do the trick on this, you can look at the graph. What are those limits based upon the subpart graph? Go. What do you think, Kendra?
Pi over 2 and negative pi over 2.
Thank you. Beautiful. Thank you. Good facts to know. That should get you very far, I believe. All right. I'm going to keep rolling today because if we talk about any of the problems. Does anybody have any questions on the web work yet? Yes.
I have one, but it's like on the super weird one. Hold on.
Is it like the one with multiple choice?
Yeah.
Yeah, me
If you
too.
get
Do you have it
one
up?
wrong, it says all of them
yeah.
are wrong.
That sounds bad.
It's bad. It's hard, and I don't enjoy
Oh
it.
no. Oh, okay. It was the one I kind of gave that tip about, right? Like with the,
Yeah.
but it's not.
But it doesn't tell you which ones you got wrong, so you're just kind of like, well.
Yeah.
Yeah.
So I've just been clicking
Me
things,
too.
hoping for the best at this point. I'm not gonna lie.
Really? Everybody?
I mean, that's six.
I had like 3 legit
So-
guesses, and then it didn't tell me.
So look.
And then I
So for this one, this is number 6, just for the recording's sake. Might be making this harder than you need to. So we've got this picture. Thanks for letting me use
Sounds
this
good.
picture. And they tell us that j of x is that cutoff, right? So that's j of x, and that is 1 over x. Oh, that's not what it looks like. It looks like that. But that's not important, really. Yeah, because their picture starts here. So this is at 1, right here. So if you are under this, if you are under j, you converge.
Yeah.
If you're above it, you diverge. That should get you through this whole thing.
That's what I was hoping,
Let's
except
see.
it doesn't tell me. I think I got caught up on 1 and 5 and 6, which aren't about those lines converging.
They aren't.
It's like, it's not. Like, the integral of qx and, oh no, I didn't hear that. So qx is that one.
Is
And
it
then
above or below h?
It's the squiggle, the green
Yep.
one.
Is it above or below h?
Does it still diverge if it's?
If it's what? Ask your question, because this is a good question to have. Explain what your.
Well, we were talking about
pain is
sine
here.
and how sine doesn't converge on any given point. This one doesn't either.
But so
But
here we're
sine
talking
still
about the
has-
integral. So don't confuse this stuff here. Like when I say this, the limit as x goes to infinity of sine of x, that does not exist because it doesn't settle down like you're thinking. But what we're thinking about here is the area under these things. That's what we're asking about here. So if I have some function and I call it, I don't know, a row of x, and it looks like this, it's not below this. This area is infinite. So any area that's bigger than the 1 over x area is also infinite and divergent. So no matter what this thing looks like, what you're trying to do here is find the area under that crazy ass shifted sign thing or whatever.
Then how come it tells me I'm wrong?
I don't know, we'll come take a look. Are you saying divergent? We'll come take a look. I think you're getting flustered. I think you're getting flustered.
I think you're right.
But the answer is, if it's under, what did I say this was? It was an H? J.
J.
If it's under J. If it's under this, whatever your 1 over x curve is, if you're under that, you converge. If you're above that, you diverge. It's just that simple. So, show me it, you enter it, let me see what's wrong.
Let me
and
put
then
my
let me
actual answers instead of the ones I just randomly clicked in hopes of getting
That
it
sounds like, you know, good starting point.
Well, I had my actual answers and then it was like, no. And so then I just clicked hope, and then I was hoping I could work backwards from there.
Let's see, how many possibilities are there? So how many are there? There's 64 possible random clicks you could
Yeah.
make.
Yeah.
You don't want to do that,
I've
can
done it 13 times already.
you? How do you know you're not even repeating, right? Like,
I kept a log.
oh my God, really?
I was so done.
No,
I'm
this
not
is
having it.
just above or below, that's all.
Oh,
That's it.
that's what I thought.
Well, let's try it, and then you show me when it's wrong, and I'll come see what's up. Lou? Yeah?
Yeah.
Is it saying wrong?
Yeah.
Let me see. I mean, maybe the question is botched, but
I mean, at least it tells you the percentage you got on it, so that tells you how many you missed, and you can just kind of figure out
Yeah.
which one you missed.
yeah. So the
Sorta.
area, oh, the one is between, so the number 1 is between those two things, okay.
Yeah.
So that could be fine. Yeah, well, let's take a look. We might actually need to work that one out. We'll do. No, I think it's going to be infinite, and I'll show you why. I think the top one is infinite because you've got a divergent minus a convergent, and that's always divergent. Oh, I guess I'm trying to raise this the
Yeah,
wrong way.
that's not such a.
Yeah, so here, I'm just going to change this to infinite, Lou, and
Okay.
try to check. And what's it saying? At least one, okay, let's go through the rest. So F, I gotta look at your picture here. So the ones that should converge for you are G, F, and P. Yeah, does that sound right?
Yeah.
Okay.
It's
I figured it out.
Well, hold on, let me please.
Okay, hang on a
gotta
second.
think.
I'm gonna need some help now because I don't know
I
what's
kind
going
of just
on.
put.
See, okay.
So this
I
one,
don't need to see, okay,
so
so
I figured out if you change the integer from converge to diverge.
Well, see, you're not
it's-
doing that,
percentage stays
you're
the
not
same, so it's
looking at what's
impossible to
above and
tell.
below, because F is below, and you're saying it
But that's
diverges.
the whole.
I know,
I think you should look more
Oh,
carefully
since it's
what you got.
below.
I have no idea,
So.
but I was like, why isn't the
Thing of,
percentage changing? Because
Diverges.
it's impossible to tell, I guess.
Okay, I swear if that's the only one, because I was
If
missing
J is
one.
your 1
Yeah.
over X, whatever
It
your
was.
1
That's
over
what it
X
was.
is, everything above it is divergent,
Hey,
everything below that is convergent.
Which
Dr.
I changed
T.
my 1 over X.
Why don't you go look, figure it out? Because everybody's got a different one.
Dr.
It tells you, it literally tells you which
So
one it is.
finally got it.
Yes, you got it?
Number
However-
3 is a trick.
Let me
Number
see
three is
number
a
3.
trick.
Let me
It's-
see number 3.
That's the answer. I got it right, but because I went through and I figured out that I
Oh,
was
is
missing
it?
one.
What is
Yeah,
H?
it's the one that you said to go above or below.
So which one was your 1 over X? Yours is J, okay. And they're saying,
I think you all got the same problem pretty much.
Yeah.
okay, that's great, that's great.
Which it should.
Because if you,
converge.
So maybe that's the one I'm looking at for you, Lou. Hold on a second. Maybe that's the one. That doesn't make sense.
because
That's what I'm
I
saying.
got like all of them right except for that one, and then I was like, okay, let me figure out which one I'm getting wrong. And
I
it was that one because if you put converge or
Totally
diverge,
disagree.
it gets the same amount.
I agree with the
I
disagreement.
don't know. That's what it says.
No, I know. I believe you. But J, so anything above J. Yeah, that's bullshit.
I'm glad I wasn't just going crazy.
Not about this for sure. Lou, which one was I? Okay. Yeah, your F was still incorrect, Lou, I think. But the next one. That's Regis Internet. Oh, it's already up like 5 times. Okay. All right. Yeah, that is convergent.
That's what I said originally.
Mm-hmm.
And then
That's
I
what
went
it
back
should
and I
be.
picked diverge, and it gives you the same percentage, so it says that you're,
Interesting.
yeah.
Yeah. So on question 6, number 3, put it's impossible to tell, but that's stupid.
Yeah.
That is a lie. That really is a lie. I don't understand why they would have that.
Yeah, because it even looks like it's going down.
Oh,
It's
yeah.
like-
Oh, absolutely. Absolutely. And if let's see, am I reading your 1 over x is j, and g is negative 2.
Literally, I was losing my mind. It's just
G is
Okay, time to switch it up.
Yeah, that's stupid. That's stupid. Well, I can't, since people have worked on it, I can't take it off, but we can talk about how to fix it up.
I think as long as you put that one and you know what the other answers are, you should be good, because that was literally the only one I got wrong.
So Lou, did you put, it is impossible to tell on number 3?
No.
That's what I'm saying you have to do to get it right. And also answer the rest right, but
Yeah.
number 3. Number 6, everybody got that? Number 6, part 3, put it is impossible to tell for some, it is impossible to know why they have that as the answer.
So J is my, my.
You're cut off.
that was the one
Yes.
I didn't change because I was like under. Okay.
I literally went through and like clicked and was like, okay, which ones are changing my percentage, and that
Are those
one was
the
the
ones
only
below it?
one that was like
No, those are
still the same percentage, so I was like, okay,
They
so
diverge.
gotta figure out which one it is.
Yeah, no, thank goodness.
Yes, the others still.
It was actually crazy, but that's fine.
And then the rest will diverge.
That's correct. Except for the dumb 3, which is impossible to tell. Wanna try that? No? Can I pay on?
Yeah.
Is it okay? Alright, let's see here, so. You probably got that open. Oh, thanks. I can never tell where I've got. So K and Q are your bad ones. Everything else should converge. Oh, good lord. Oh, God, help me out, get me back things. But how do we get, do this?
It's like a 5-year-old computer.
Hey, they work, right?
Should that be 5?
No, that's infinite, that's right. And f of x should diverge. This question is whack. Maybe your H like wants the actual answer. Yeah, I gotta look at this thing. K and Q, that's it, okay. Those are the bad ones. It was J, right? It was J, okay, yes, you're J, okay, so K and Q, I'm like, how many times do I have to look at that? Apparently not multiple. So, that one diverges because of the J. That one diverges, that one. I'm gonna say diverge here just to see if it's being stupid.
Yeah.
Oh, K and Q are your ones that converge.
Yeah.
So you have to say converge on that one. Diverge. And Q, you're saying all of them diverge. But K and Q are your good ones, right? Or were they your bad ones? Did I get
They
that
were
right?
the top
God
ones.
damn it. Diverge. Diverge. Everything else should converge. Let's just see if that works. Let's try that. No.
Forgot.
What did I forget? Yeah, I was hoping,
Diverges.
yeah, I had diverge.
Oh wait,
Diverge.
that's diverge.
That is diverge. Right, not impossible to tell. That's the one that was only impossible to tell. Everything else is, okay, so let's change that to impossible to tell. Okay, I will never use this problem again. Unbelievable. That is infinite.
That is below, so that diverges.
F should converge, yeah, it should converge.
Converge.
It's below. The two that don't converge are K and Q. Everything else is below.
Oh.
So, converge.
Converge.
Let's say, this might be the one it wants. Diverge. Converge. Diverge. Submit, and if it's wrong, it's because it once does not. It's impossible to tell, I guess.
There you go.
That's it.
Thank you.
You're welcome.
Thank you so much.
You're so welcome. That's frustrating. You're doing good, Carly. Okay, awesome. You doing good, Josh?
I am.
You're doing better now that you got that?
Yes.
Okay, great. How's it going, Cassie?
Pretty good.
You should do okay after class on Wednesday?
Mhm.
Okay, great, good. Don't bring it up, right? Yeah.
I just didn't like the sign came out to 2. I
Yeah.
didn't like that.
Yeah, oh, you don't like that?
No.
Oh, that was the part that was the
It was the
second
whole
part?
last like 10 minutes. I was
Okay,
like,
okay.
no, I don't agree.
Okay, fair enough.
Causes me anxiety.
Just let it go.
Yep. I just don't think about it now.
Fair enough.
Yeah. We doing well? Okay, that's good, that's good, that's good. Yes, actually, oh yeah, corrections, I should have asked for those at the beginning of the hour, but I'll take them now, sounds great, yes, please. Okay, oh, okay. Thank you.
Get mine out.
Oh, okay, beautiful, thank you. Many thanks.
I'll just take one. Yeah.
We'll have to find a stapler.
Yeah.
Yep, I would think Peace and Justice has one. Okay, yes. Yeah. Yeah. Good, oh, good, so. Those are the facts you need now. Yeah, I mean, you need that graph, really, because in the end here, so you've got b going to negative infinity. So b over 2 will still go to negative infinity. So you've got, this one's already fixed, right? That's just arctan of 2, whatever that is. There's nothing you can do with it, it's just arctan of 2. But here you've got arctan of basically negative infinity. What would that be based on that graph? That's it. Yeah. That is the limit of the original function, but that is not the limit of its antiderivative. Right? So when I look at this, the limit at negative infinity, absolutely 0, and you got that graph, yeah, perfect. But the antiderivative of this is not that, it's this arctan. And that's where we're at now, yeah? Make sense? Cool. Thank you. Why don't we take some time now, Lou, since nobody else has any questions, you can tell me your stuff, you want to tell me.
What we talked about here.
Yeah.
Is an unbounded region. Identity. There we go.
Yeah.
Is it?
That's right.
Really?
Yeah. Yeah, why, so you've got pictures of space. Yeah, so this is kind of like space is infinite but closed on itself. It's kind of a similar idea, but that's more about the curvature of space-time. This is a little bit different, this idea, but yeah, this comes from the curvature and space-time, and the topology of space-time more than something like this in particular. This is very complicated.
Yeah.
I got a great book. Here's a book I recommend to you. The Shape of Space by Weeks. You can probably find a PDF for free.
So sort of like the saddle model of
Yeah. Hyperbolic
hyperbolic
versus spherical.
Yeah.
Yeah.
Is that what's?
That's it. That's it. Yeah.
Oh my
Yeah.
god.
So like, the toral, like a torus. Yeah, exactly. Yeah, let's let it work real quick. Let me just get, may I?
Yeah.
Yeah. Let's find this, because I think we can find you a free copy. Because it's been out forever. It's one of my favorite books. I think you would love this book. Weeks. They want to pay. They want you to pay for it? Never. Not that much anyway. You can buy a used copy off eBay for like $15. That looks bogus. That looks bogus.
Yeah.
That looks like.
They got asked for information.
Exactly. That looks bogus. Wouldn't do that one. Go to the images. Sometimes that's a good way to find a PDF. Look for, like text in here and see. Ooh, that's cool. Small pictures. No, his book is like all black and white with hand-drawn images, and it's really cool. It's really cool. Go back, let's go back to the main search real quick. Did we check on that one? I think we did. That was garbage.
Yeah.
They want $60. They're out of
They want
they're out of their
$60.
minds. That looks scary. I don't think keep pushing it. I think that looks really, that looks terrifying. And the delay was a little scary. Let's just check out this.
Gluing.
This is based on the book.
Sounds fun.
So this, I think this could be right up your alley. I'll see if I can find a free copy of the book for you, or I'll just look online if I can.
Oh, that's 3D.
Yes, it is. Yeah, exactly. Yeah, that's Euclidean space. That's
It's not.
no
It's more than
curvature.
that. Right?
It's more than, I think it's more like 11.
Well, like string theory, it's like 11.
Yeah. Oh, this is it. This is right up your alley. Yeah, you could at least get something out of this, but
It's
I'll
funny to
try.
think about, like,
Double
the universe
torus.
looking like this.
Yeah, that's really fun stuff.
What?
There you go. Yeah.
That's weird.
This is probably right up your alley, isn't it? Yeah.
How did they come up with this?
Those are handles, so you like, I'll show you on the board.
Oh, this is like,
It's gluing, that's what the gluing
it's like
part
a
is.
cup. So that's where this stuff falls.
Yeah, you know about the torus and the cup already,
Like,
it sounds
yeah,
like.
the torus and the cup.
Yeah, but you can take, so you take like a sphere, and you can glue handles onto it, so you glue one handle onto the sphere, and then it becomes a donut.
Uh-huh.
And then there's another thing you can put on, it's called a cross cap. And it's where you take a sphere and you sew together antipodal points. So you sew them all together. And you can try to do this, but you can't do it in reality without a fourth dimension. But that's a cross cap. And then you attach those on here too. So these are like Mobius strips,
Yeah.
right?
But
So-
instead it's like a sphere.
Yeah, it's like sewing a Mobius strip onto the sphere. Yeah. Then you get like Klein bottles.
Oh, that's what a Klein bottle is, isn't it?
Yeah, Klein bottles where you take a Mobius strip and you sew together.
All the sides.
Yes, just sew together. Yeah, start to make a tube out of it, and then it climbs out on you. Yeah. I'll find that book. I'll find that book for you. What I'll do? Let me do rounds. Let me do rounds.
Yeah.
Anything? Anyone doing good? You're still good. Did you get that one? Or? Oh, it's a new one. Good, good. Yeah, yeah. Did you have a question? Yeah. It is. So why is that? Let's talk. That's a good question. And you're not sure, I guess, is the answer. Okay, so this thing in front, let me do this on the board. Which one is this? Number 7.
I was just about to ask about that one.
What's that?
I was just about to ask.
Good, it's a good one to talk about, huh? Okay, awesome. The key of number 7 on the web work is that at plus infinity? Is that a positive infinity limit, Kitra, or?
Yes.
Yeah.
Vivian? Yeah. Okay, so we got this. You've got some constant k, and then you've got e to a negative. Well, how about we just do this? Cx, and c is a constant. So if c is positive, you have exponential growth. So let's look at the case here. C is positive. This is C positive, K positive. Got a positive number out front, got positive, I've got exponential growth. This would be K negative. Either way, that thing blows up. But if I've got C negative, life is really good. So if C is negative, and if C is 0, you don't even have an E there. And if C is 0, the answer is K, because that's just a constant. But if C is 0, you have this. This would be K positive. This would be K negative. Either way, it's dying out and you have exponential decay. So here the limit would be 0, no matter what. And I think that's the case you have. Yes.
Mine doesn't have a constant, mine has an x in front of it.
Oh, does it?
Yeah.
Oh, I didn't see that. Okay, let's talk. Okay, that's even better. Good. So we do need L'Hopital's rule. Okay, that's all right. It's going to be all right. But I can show you a fact that we'll come. Let's do a fun fact about L'Hopital's rule. And so it's another good, like, instant rule for how to do these things. So you've got something like, and then I saw, Vivian, you had like that or something. Yeah. And Kitra's just kind of like this.
Yeah, mine has a 3.
Here, let's add them together and get 5. Same thing. So when you have a limit, first it's good to look at each piece. So this piece is going to infinity. Where's that piece going? Just that 0, yeah. So this is an indeterminate form. And I need to convert it into a fraction and use L'Hopital's rule. So what I'm going to do, so when you have this, then you convert to a fraction, use L'Hopital. So this thing here actually converts to a fraction pretty nicely. Just get rid of the negative exponent, and what you're going to get is that. Yes, Kitra, yes?
It's, I don't know if this makes a difference, but it's the limit of the integral of that.
Oh, that problem. Okay, well, this will still be part of what you have to do after you do it. You need to use parts first.
Yeah, I did that, and I got this thing.
So yeah, so you'll get like some, and yours was like 3x or something, right? So you'll get this with some constant in front of it, I don't know what. And then you'll have plus or minus integral 0 to infinity of just good old e to the negative 3x.
Yeah.
And then this one you can just do as if it were fresh. But here you still have to do that, essentially.
Yes.
That's the part I'm talking about.
Okay.
Because you'll still have
Got
to do an infinite, does that make sense?
Yeah.
Yeah, so your top limit will be infinite, and you'll put that. I'm abusing notation by putting this here, friends, so like that's, it literally should be a b, and then a limit as b goes to infinity, like that. And you're with me on that one, Vivian? I'm sure you are. Let me know when you're with me on this. It feels good. And Kitra, you see where I'm going with this? So Vivian, yours was like a 2x, right? So you've got like this, I don't know what, you had some number out in front. But, so what I'm saying is after you put the b in, you've got like this. So now look at the fraction. Where's the top going?
Infinity.
Infinity, where's the bottom going?
0.
Nope.
Isn't it?
Careful. That was where,
now it's going to.
now it's going to infinity.
Ah.
Now I've got a fraction, infinity over infinity, and now I can use this, because the L'Hopital's rule only works if you've got this or this. Only can use L'Hopital. So when you have this game going on, you have to invert one of the things and either get a 0 over 0 or an infinity out of it, over infinity out of it, and then L'Hopital. So, so if I L'Hopital this, let's do it with respect to b. What's the derivative of the top with respect to b? What's the derivative of the bottom with respect to b? Yeah, or 5, the 5 comes out, right, there, yeah, there would be a 1/5 net, but we got it. You're integrating, I think maybe if you were thinking a 1/5 came out in front, you were using my nice, which I appreciate, you were using my sweet 1 over k shortcut, but this I'm differentiating top and bottom separately here. I'm going the other direction than we're used to going. So now I've got fixed top over bottom blowing up. Where does that go? Here's what's happening to this.
0.
0, right? It's doing this. It's like, yeah, it's getting more zeros. That's headed to 0. Ask. Do you agree with that?
It's going to 0.
It doesn't equal, yeah, it doesn't equal 0, but it is tending to 0. So that is right, Josh, yeah. So if you agree with this, then Vivian, now I've got a limit, so just think about this new problem. Top is fixed, not expanding. Bottom is getting bigger and bigger because I've got this exponent b getting bigger and bigger. So this literally is acting like this, right? Getting tinier and tinier. And that's when we say that 0, that's what we mean. It's getting tinier and tinier. Okay, yeah, that feel a little better?
Yes.
Kitra, that helps in yours.
It should be 0.
That part of the limit is 0. That part of the problem goes to 0, which your answer isn't 0 in the end, because you've got other stuff going on. Let me do an example. And actually, here's a great rule of thumb. I was going to say this, but limit as x goes to infinity of any power of x over e to any thing times x. That's always 0. No matter what the power, this is always 0. No matter what the exponent on x is, no matter what the b is here. That's always 0, unless, I mean, here b has to be positive, to be clear. E exponential things grow faster than any polynomial. So that's really what that's saying.
I've got that,
Okay.
but
What? Yeah, it's okay.
that only addresses like the first section. So how do I address the second
So
section?
if I had this problem, integral from, where's your start? Is it 0 or not?
Minus 6.
Sure, let's start 6. It's gonna be slightly different anyway here. Do I want, I don't know if I wanna do that, but we'll do this. Yeah, let's do our little group project integral with the sum of both your b's there. So if you graphed this out, it would look like this.
Yes.
Yeah, and we're picking it up, like here, so we're finding that area, right? Yeah. So I gotta do parts first. And I'm not gonna think, I'm gonna forget about the limits. And then, so the parts, I'm gonna let u equal x, dv equals e to the negative 5x. It's all looking good. And then uv. And this is the kind of stuff that both you and Vivian were having a little bit of unhappiness with. And then minus integral b to u is going to turn into plus integral. So let's just stop there on the parts thing. See if that,
Yeah.
But so then let's put the limits back in. This one I'm going to rewrite the original limits, but this one I know it's really going to be 6, right?
Yeah.
6, and then I'm going to put limit as b goes to infinity in front of that. That 6 and that b are disturbingly similar. So
Yeah.
let me do that. Yes, we're good?
Yeah.
Just looking at the folks who are watching, see, you good? Yeah, all right. Okay. So, then let's do this. I'm gonna plug in the b. Limit as b goes to infinity of negative 1/5 b e to the negative, what the? 5x, okay. Negative 5b. And then I plug in my 6, and that becomes plus 1/5 6 times e to the negative 30, which is stupidly small, but not 0. So that's a constant. That part's done. This part's gonna die based on that rule up there, but let's address it in a minute. And then this part here, I'm just gonna go ahead and knock out this integral. So this goes to another negative 1/5 e to the negative 5x from, and let's abuse, this is horrible, I hate doing that. Because it looks like I think infinity is a place I can get. But, so I'm just, these are my disclaimers. I know it's not. So what happens to that? That's b over e to the 5b. And so that dies. Yeah. And I could L'Hopital it if I want. Right now it's infinity over infinity, and if I L'Hopital it once, I've got 1 over 5 e to the 5b. Fixed thing over expanding thing. Unboundedly expanding, that goes to 0. So this thing goes to zip. But that's the fact. That fact up there is a great fact to remember, and you could also write it like this. I think I'll do it because that goes to 0, no matter what x is, because it's just this fraction. Exponential things win. Yeah.
0 and it said no.
Well, hold on, we're not done. Hold on. Well, 0's not the answer. Because look, I mean, that part's 0, but there's plus other stuff. This isn't gonna be 0. That's not 0. So part of it's 0, I agree. And web work would agree. But web work isn't asking about that part. So right now, at a minimum, at a minimum, I've got this horrible 6/5 e to the negative 30th, which is ridiculously tiny. But then I gotta do this now. So this is negative 1/5 limit as, put a b here, right? Replacing that with b. Limit as b goes to infinity of, you plug your b in. Oh, let's put 1/25, sorry. So this actually becomes negative 1/25, because that times that and the negative. And then I've just got e to the negative 5b minus, and I've already pulled that 1/5 out in front, and the negative, so minus e to the negative 30th, for God's sakes. I'm gonna stop. I don't wanna see your expressions of horror. Just ask me, tell me. Say it. What's that?
You're a vampire.
Oh. Where does this go? 0, because it's 1 over e to the 5b. So my final answer is that plus 1/25 e to the negative 30th. That's just dumb. Hopefully yours isn't as dumb. But it ain't 0. What's that?
Mine's a little dumber. Because I have 8 as mine. Instead of 6, I have 8. So mine's even smaller. Anyway.
Is it?
Yeah.
What did you get, e to the what?
Negative 40.
I mean, hey, if we were like physicists doing quantum work, this would all be right. This would all be fine. So I would not try to put this in a calculator, because you'll get 0 out of your calculator. So I would just enter this in its raw form.
I'm gonna leave.
Okay. Goodbye.
Oh, I think I just confused on like, that makes sense, I think, it's the part where it's like, where is it going? I think that's where I'm lost, but I think I just need to watch the video again.
I think so too. And then, like, use some YouTube. Go to Patrick JMT and look at limits at infinity. Patrick JMT. This is my go-to YouTube person. Patrick JMT, go to his page and type in infinite limit, or limits at infinity. Or L'Hopital, anything you want to know about calculus that I'm not showing you, or you want to review, there's your man. Oh, you'll be there.
I'm always like confused when I'm not, and then I did this.
Hey, that is math, right? That's what we're here for, the thrill of victory, so. Thank you.
Thanks, Dr.
Thanks.
Can we stop this?
Yes, please.